Hey Theo, welcome back. Today we start a new series in designing Instagram. Today we start with the functional requirements and non-functional requirements. And after that we talk about capacity estimation and we will end this video by talking and describing the high-level design. I guess this video series will be even more longer than the WhatsApp series since we have a lot of things to cover in this system design. Okay, so I guess this video is highly inspired by the AlgoMaster newsletter. I will put the link in the description below. So if you want to see them, yeah, I'm not sponsored by them, so but I guess they are pretty good newsletter to tackle. So we want to design Instagram, and in any system design interview, you have to follow a specific framework. And in this framework, first you start understanding what you're actually designing. This means that you have to know your functional requirements, you have to know your non-functional requirements, and you have to make some capacity estimation to make sure that you understand the things in the best way possible. We start with the functional requirements and non-functional requirements. After that, you propose a high-level design, and this is what we'll do in this video. And after that, you will take like a deep dive in your components, and we will do this in next videos. And endlessly, maybe and in the end, sorry, you will maybe talk about some things to improve, like how to improve scalability, things like that. So let's start with the functional requirements. So we need to create a system that the users can upload photos and videos. User can add captions to their posts. User can follow and unfollow each other. Users can like, share, and comment on posts. We need to support multiple images, videos in a single post, which basically a carousel update. We need to add like user also can view a personalized feed consisting of posts from accounts they follow. Users can search by username and hashtag. Okay. The non-functional requirements will be we need our system to be we need extremely low latency. The feed should load fast. We need our system to be highly available. We will accept to have some sort of eventual consistency because a slightly delay in users seeing the latest post from accounts they follow is quite acceptable. We need our system to be highly scalable. Also, we need our system to be high. We need to add to our system high durability, so the upload photos, videos shouldn't be lost at all. Okay, let's talk about capacity estimation because there is a lot of things to talk about here. First, let's talk about the user base. So we assume that we have 2 billion monthly active user. So we have about 50 million daily active user. In the estimation in read and write requests, we will suppose that the post uploads that we have 100 megabyte media uploads per day. Each upload generate meta data. No, it's not megabytes, it's metabyte. Sorry. So total write requests, I guess it will be this number. I will not go through all of the numbers right now because I guess you can read them. Hopefully you can read them. In terms of the feed reads, we assume that with an average user scrolls through 100 posts per session, we will have like about 500 million daily active user, and we have about like 100 posts, so we have about like 50 billion feed requests a day, and this is a lot. Assuming 80% of the feed reads are served from the cache, and actually this is a real number, like 80% of the feeds will be served from cache, and we will talk about this in further in further videos. So, and if you want to talk about some assumptions, we have 20% of daily active users that will upload media every day. 80% of uploads are photos, 20% are videos. Average photo size is 1 megabyte. Average video size it's 10 megabyte. And the daily, if we want to make a daily storage calculation, we will have about 80 terabyte a day for photos and 200 terabytes a day for videos. If we want to talk about database storage, so If I want to talk about metadata per post, it might be 500 bytes. Total post in a year could be 100 million multiplied by 365. We might have about 33 billion posts, and the metadata storage per year will be 990 terabyte. We need to also think about the hot cache size, because we store recent and popular 1 billion posts. We will assume each cache post takes 2 kilobyte, and the cache size will be like 2 terabyte for active posts, and we can use this in Redis and Memcache. Okay, so let's start by going to our high-level design. So right now we know our functional requirements, our non-functional requirements, and we did talk about the capacity estimation. So exactly right now, I hope that we know exactly what we are designing. So the system looks big. Because of that, I said this video series will be really long. So maybe it will be like 12, maybe 20 videos. So yeah, just be patient with me. So let's take the pen and start one by one. So first we have the client. Everything starts with the client. These are mobile apps or browsers. They interact with the backend via a load balancer or an API gateway. So this is a load balancer and API gateway. Okay, we have the load balancer here, or the API gateway. This will distribute traffic to the correct services. It will ensure scalability, security, and rate limiting. It acts as a single entry point for all client requests. Okay, next we have the user service. So the user service will handle user profiles, user profile data, sign-ups, logins, update, all of that things. It will use cache. Basically, this cache could be Redis or fast access to user profile. We have here a user DB. The user DB could be for persistent user information. It could be SQL or NoSQL. I would prefer to use SQL. Next, we have the engagement service. So the engagement service handles all interactions like likes, comment, follow, etc. It pushes the engagement events to the message queue. Oh, okay. To push it to the message queue, and it will store the structured engagement data in the like, comment DB. Next, we have our post service. The post service, it's responsible for creating and uploading posts. It handles media upload to object storage. We're using here a blob storage. Yeah, it will handle it. Also, it will save post metadata. I guess I should. There should be connection between post service and blob storage. I will check that. I guess I made a mistake here. Let me check quick fast. Did I make a mistake here? Yup. I made a mistake. Okay, let me make sure that I made this. I clear this. So let's put this like that here, and this like that here. Hoppa. Yup. And the post service should be connected with the blob storage. Yup. Okay. This is okay. I guess this is right now. This is right. Okay, so let's talk about the post service again. So the post service is responsible for creating and uploading posts. It handles upload to object storage here, or the blob storage. Oh, where is the pen? To the blob storage here. Oh, this is too thick. To the blob storage here, and this could be like Amazon S3, for example. It saves the post metadata like caption, tags, author, timestamp in post metadata cache for faster read, and in post metadata database for durable storage. It sends messages to the message queue for async processing by feed services and search services as well. Next, we have the object storage in the blob storage and the CDN. This will be our main object, our main storage for storing images and videos. The images and videos will be uploaded to this object or this blob storage, then served globally using CDN for low latency media delivery. And we did talk about low latency in our non-functional requirements. Because of that, we added CDNs. I guess next we have the feed service. So the feed service is responsible for generating and serving user feeds, like homepage content. Basically, it pulls post data from the post metadata cache and post metadata DB. It uses a feed cache to store personalized feed per user. Its workflow is pretty easy. It's like user A follows user B. User B posts something. The post service will send it to the queue, and the feed service will pull this feed service update from the queue, and it will show it in the feed. Next, I guess we have the search service. It enables users to search for users' post hashtags, etc. It uses a search index, like to index and search efficiently. It uses a search cache for commonly queried terms. It updates come from post services via the message queue. Okay, we did talk a lot about message queue, so let's just talk about it in details. So the message queue will act as the coupling layer between services. It ensures first it ensures asynchronous processing. It have retry mechanisms. It ensures smooth scalability. It's used by post feed, from post to feed, and also from post to search. It will be used from engagement to analytics as well. All of these are services. We can talk about some example walking through so we can understand how this will work. So let's talk about creating a post. So the client will upload an image and writes a caption. The clients will send this to the load balancer, and the load balancer will direct it to the post service. And the post service will first upload media to the object storage. It will upload the media to the object storage. Number 2, it will store the metadata in DB and cache. Number 3, it will send the event to the message queue. And the feed service and search service, I guess the search service also should be connected with the message queue. These services will consume the message and update data accordingly. If you want to talk about loading the feed, a client requests from the load balancer a feed. For example, like when you open your phone, you're basically requesting a feed. When you open your homepage in Instagram, so you are basically requesting a feed. So the load balancer will go through the feed service, and the feed service will see if there is a cache. It will pull everything from the cache and send it back. But if we have a cache miss, we will the feed will connect it with the metadata cache or metadata DB. For searching content, if you want to talk about the search service, this one, users will enters a search term, for example, like blah blah blah, anything like that, and it will be basically redirected from the load balancer. Everything starts with from the load balancer. And basically it will query this search cache. It will query it from the index or in the search. It depends on we have a cache miss or a cache hit. I guess that's it for this video. I guess this video was quite longer than I expect. It was like 15 minutes. Usually I make videos for 5 minutes, not more than that, but this was a long one. So yeah, in the future videos, I guess we will talk about the database design of the relational databases that we have, and after that I will create another one for database design for the non-relational databases on this system, and after that we could talk about the API designs, and I guess next we could focus more on the deep dive, and yeah, and that's it from my side. I hope you like my content, guys, and see you.